Let's go ahead and try another example of linear programming. I have done another example in a separate video, so you can check it out before approaching this problem. I'll leave the link in the description box for you to do that. Let's go ahead and try this problem. Suppose a music academy conducts a training course in vocal and guitar for both amateur and professionals. Allocation of classes and cost of conducting the classes are given in this table. And we want to know how many classes of vocal and guitar should be arranged to minimize the cost. So that's your objective function, minimizing the cost function, and meet the class hour requirements. What is the minimum weekly cost of conducting classes? So let's go ahead and do that. So first of all, we're going to set up two different inequalities. So as you can see here, for amateurs, 2 vocal hours of class and guitar 3, and we have number of hours listed. Minimum class hours to be attended is 15. So minimum means 15 is the lowest. You can attend more. So we're going to use the inequality greater or equal to. So you can have more than that, but you cannot go lower than 15. For professionals also, vocal 1 hour, guitar 2 hour, minimum is also 8. So we're gonna put greater or equal to. And then the last part will give us the objective function. So we can write down the following. Our objective equation or function is the cost function. So let's call it C. So it's gonna cost $7 per class for vocal. So 7 times, let's introduce some variable. Let X stand for vocal and Y stands for guitar. So that means $7 for vocal. So that's 7 times X plus, and then Y is going to stand for guitar. So that's $12 for guitar. That's Y. That's the one we're going to be minimizing. Now let's go ahead and write down the constraints. So we have 2 categories, amateur and professionals. So our constraints inequalities are going to be, so using the first row, we have 2 hours for amateur, so that's 2 vocal hours for amateur, so that's 2x plus 3 for guitar amateur, so that's going to be 3y greater than or equal to 15. So that's one inequality. And for the second category, for professionals, 1 hour for vocal and 2 hours for guitar. So that's 1x plus 2y. Again, minimum is 8, so that's greater or equal to 8. And also you want to make sure these x and y are positive, so we also have these constraints for these to be positive. All right, now we're going to go ahead and do the following. We will graph these inequalities, find the corner points, find the feasible region, and then we'll pick values within that region to see which one will minimize the cost. Let's go ahead and do that. So I will only consider the first quadrant because we're assuming x and y are positive. So let's call this the x-axis, that's the y-axis. So the first inequality we're going to graph is this one. So that would be 2x plus 3y greater or equal to 15. So for this inequality, we're going to find the intercepts. So for x-intercept, we set y to 0, so you have 2x is equal to 15. So x is about 7.5, 15 divided by 2. So let's suppose this is 7.5. And for the y-intercept, we're going to set x to 0, so you'll have 3y is equal to 15. So y is equal to 5. So we will have y-intercept right here. So I'm just going to draw the line before I label the point. Suppose this is 5. That's the y-intercept. Now, which direction do we shade? This way or that way? Well, you pick a point within those particular region. Let's say I want to pick 0, 0 because it's easy to test this point. If you plug 0, 0 into the inequality right here, x equals 0, y equals 0. So you have 0 greater than or equal to 15. That's not true. So we don't shade below, we shade above the boundary line. So we're going to shade this way. So something like that, just showing you an idea of this. Now for the second inequality, we do the same thing, finding the intercepts. So I'm going to go ahead. So let's go ahead and do that. We have x plus 2y is equal to 8. So if I said for the x-intercept, I said y to 0, I have x equals 8. So let's suppose this is 8. And for the y-intercept, we're going to set x to 0. So that would give us 2y is equal to 8. So this is for y-intercept. So you'll have y is equal to 4. All right, so let's draw that line. So perhaps something like this. And then this is the 0.04. And now we shade in the region. So again, you pick a value. Let's pick 0, 0 again. Plug it into the original inequality right here and see if that makes it true. So x equals 0, y equals 0. We get 0 greater than or equal to 8. That's not true. So we don't shade below, we shade above. So this is what the second one will shade in. And x is greater than 0, y is greater than 0. So that just bounded to the first quadrant. So we're not going to exceed these lines. And our region is where the two inequality intersect. So hopefully you can see it. It's from this point, everything here. And then also there's an intersection right here. That's one of the corner points. So I'm just shading in so that you can see this is our feasible region or the solution region. Let me go ahead and erase these so that they don't overlap too much. And also this. So that is the feasible region. So we need to go ahead and find the corner points. So that's where we know where to minimize the cost function. So we have a corner point right here. So our corner points for this example are 0, 5, and then this intercepts on the x-axis. We have 8, 0, and we need to find this right here, the intersection. So for that, we're going to solve the inequality right here. So we have 2x plus 3y. So find that point by solving that system. So we have 2x plus 3y equals 15, and then x plus 2y equals 8. We're going to solve this. So I'm going to go ahead and multiply the second equation by negative 2. So that gives me negative 2 here, and negative 4 here, and negative 16 there. Now I add them up. So the x cancels. You have 3y minus 4 y. That's negative y is equal to negative 1, which means y is 1. So that's one of the point of the intersection. So this is the y value is 1. It's a little off scale, so please ignore that. How do I find the x value? Well, I plug it into the original. So for the x, we plug it into either the first or the second. I'm going to use the second because it's easier to compute. So we have x plus 2y, so y is 1 is equal to 8. So x is equal to 8 minus 2, that's 6. So there you go. This point right here is 6. So another corner point will be 6, 1. All right, now let's go ahead and get rid of this, and we can find where we'll have the minimum value for the objective function. So our objective function is right here. C is equal to 7x plus 12y. So I'm just going to go ahead and copy this down here and test. So there you have it. So at the point 0, 5, what is the cost? So x is 0, so this is 7 times 0 plus 12 times 5. This will give us cost of $60. That's how much it's going to cost. Now, what about if you have 8, 0? So the cost would be 7 times 8 plus 12 times 0. This would give you about $56. So that's how much it's going to cost when x equals 8 and y equals 0. And the last point we're going to test 6, 1. The cost is 7 times 6 plus 12 times 1, which would give us about 42 plus 12. That's 54. So this gives us the lowest cost, which means we so this is the lowest cost. So this will minimize the cost function 6, comma 1. So now if we go back to the problem, we wanted to know how many classes of vocal and guitar should be arranged to minimize the cost. So we need to arrange X is representing vocal, 6 vocal classes and 1 guitar class to minimize the cost to $54. So that would be the cost for this particular scenario. All right, let's get busy. I hope this helps. I'll see you next time.